Well, next we're going to discuss the pollutants from the electroplating industry. So we have discussed a lot in the previous page, okay? They contain acid or alkali, heavy metals, then there are ions and cyanide ions, okay? Well, cyanide once again, okay? Of course, we know that cyanide is very highly toxic, okay? And the heavy metal is also toxic to human bodies or even the marine life, okay? And the acid and alkali will change the pH value. This will prohibit or kill the marine life, okay? So we're going to do is try to reduce the volume or recover the usable materials, okay? For example, we can use precipitation to remove the heavy metal ions for recycling and control the pH value, okay? And that's it. So here shows these are common chemicals we're going to use in nickel plating, okay? In nickel plating, nickel plating and chromium plating are very important in our daily life. For example, chromium plating will generate a mirror-like surface, okay? For example, in your home, okay, the water tape, okay, the water tape, this is shiny mirror-like surface because they are chromium plating. But the chromium plating, they are not of treatment, okay? Before, for example, they will need to play a layer of copper, then play a layer of nickel, finally play a layer of chromium. So they include 3 electroplating. So you can predict a lot of chemicals used, okay? So what's the use or function of sodium sulfate, okay? This is easy because sodium sulfate includes sodium ion and sulfate ion. Both of them are weak oxidizing agent and weak reducing agent. They will not get the preferential discharge. So their existence is just to increase the conductivity of the electrolyte, okay? Well, the second one is H3BO3. Well, we have no idea what's that, okay? But from the formula, we think that it should something be an acid, right? Is to control the pH value or make the electrolyte in acidic condition, okay? This is important because you can predict that if the solution is in base condition, well, then most metal ion will form precipitate and our electroplating process will be stopped, okay? So use label diagram to show the electroplating process. Well, easy. First of all, you must include the battery, right, or power supply. And this is nickel, and this is our object going to play, and in a solution that contain nickel 2 sulfate, sodium sulfate, and H3BO3. Well, finish, okay? And half equation this is still handle. So yeah, we included this is a steel handle, okay? Of course, the nickel 2 ion will receive electron to form nickel. Well, so maybe you will ask, how can I know that nickel got 2 positive charge? Well, please refer to this formula, okay? Suggest a method to remove nickel 2 ion. Yeah, easy. Add sodium hydroxide solution to form precipitate, which is nickel 2 hydroxide. Then you filtration, okay? Use filtration, can do it, okay? Of course, you are feel free to use formula in your examination. Finally, suggest 2 reasons why nickel 2 are removed. Well, first of all, because nickel 2 and are toxic to who? To marine life. The second one, nickel 2 ion can be recycled to save money. Okay. But finally, we're going to see the final question in our notes. Okay. Now, first of all, in these pictures, you are going to ask, there are two solutions of sodium chloride. One is very dilute, one is concentrate. Okay. We have no idea which one. Okay. So, first of all, we need to draw the electron flow. Well, this is negative, so the electrons should be here and here. Okay. And electron, okay, you should pay attention, there should be electron here too. Well, this one is important because this one is not a salt beach. In salt beach, we have no electron to pass through it, right? Correct. But this one is wire, okay? So we have electron here. So identify the cathode and anode. Okay, cathode and anode. Well, cathode is going to undergo reduction. That means they receive electrons. So cathode should be dot, and anode should be C. And here, electrolytic cell 1, anode is undergo oxidation. That means they lost electron. There's A, then cathode is B. Easy. The second one is identify the gaseous product. Okay, so you have two choices. Okay, either from the half equation, or simpler case is from the volume. Okay, well, this one is 1 to 1. That means one of them is hydrogen and one of them is chlorine, but we have no idea which one is which one. Okay, and here one of them should be hydrogen and one of them should be oxygen. Okay, so easy. Boy is got large volume, right? So boy should be hydrogen, and then A should be oxygen. But in electrolytic cell 2, okay, because dot is a cathode undergo reduction, that means they should form hydrogen, and C is chlorine. Okay, well, in fact, in the real situation, C, the gas volume, should be a little bit smaller than that of D, because chlorine is a little bit soluble in NaOH. Okay, we have discussed it before. Then, in terms of the preferential discharge, how the gas is formed in C? Well, C is here. C is because chloride ion concentration is much greater than that of hydroxide. Okay, so according to the preferential discharge, okay, more concentrated species will form or be discharged first. Okay, will discharge form. Oops, sorry, chlorine. Okay, then suggest a chemical test for product in A and B. Well, A is oxygen, B is hydrogen. So easy, right? Oxygen is used growing spring, and it will rely in oxygen. The hydrogen is used burning spring, and it will give a pop sound in hydrogen. Okay, well, finally, is there any change in pH value in the electrolytic cell 2 after electrolysis? Okay, now in cell 2 we got hydrogen, hydroxide ion, chloride ion, and sodium ion and chloride ion. Okay, because they form hydrogen and chlorine. That means hydrogen is consumed, chloride is consumed. Okay, so we only have sodium hydroxide remains. Okay, yes, of course, yes, the pH value will increase because sodium ion and hydroxide ion are remained as hydrogen ion is removed or consumed in electrolysis. Okay, so the solution remains to be sodium hydroxide. So of course the pH value will increase. Okay. Oops, there's the end of the session. Okay.